So weather is the instantaneous type thing. So the day-to-day, what's happening outside your window, what the weatherman will tell you, the weather's what that's going to be like today. And now climate is different to this. So climate is more like the long-term trending of weather, or a long-term average of weather, something that you measure over a much longer time. Now, climate variability is where climate changes on a time scale that is smaller than what you would see climate change operating on. So just like weather can vary hour by hour, climate can vary over months and years. So that's what we call climate variability. Now, climate change is the change that we see happening on a much longer time scale, so from decades to millennia. So these changes, it is possible to see those, and it could be because of climate change, and it could be because of variability. Now, when you talk about historical climate change, going back to when the Earth was born, let's say, we call this paleoclimate. So I have a diagram here that shows paleoclimate. Now, this is the average global temperature of the Earth going back 500 million years. Now, we didn't take the temperature of the Earth back then. There's all sorts of science that can lead us to these conclusions. But what you'll notice is that the time scale is quite complicated. It's a change in time scale. So down this end, this is going from 500 million years to 100 million years ago. And this time scale changes. Now, what you can see here is some climate change and some climate variability, which is all natural. So this could be caused by solar activity or volcanic activity. And if you go on to much more recent years, so because this scale has now changed, you can see the variability on, say, like 0 to 5,000 years ago. So just bopping up and down here. The issue is that these projections here are showing something that's much different to what we're expecting. So this is a projection for 2050, and this is a projection for 2100. And it's showing something quite alarming. Now, if we go to something more recent, so the next picture, this shows you a graph from the Met Office. So the Met Office is the meteorological office in the UK. It's the UK's National Weather Service. And this is a graph to show the average temperature anomaly. Now, what the anomaly is the difference between the annual average temperature and a base temperature, or a reference temperature. Now, the reference temperature you can see here. So they've taken a reference period between 1961 and 1990 and calculated an average for that whole period. Now, if you then compare, so 1960 is about here to, and then 1990 is over here. So they worked out the temperature average for that time, and then looked at the difference between that temperature for earlier years and then the later years up to 2016. So you can see that the average before was much lower than this reference temperature, or some amount lower. Sorry, I shouldn't say much lower, because actually it's only a matter of half a degree, which does make a difference. And we can see going up to 2016 that the temperatures are going up to 1 degree above this reference temperature. So we're seeing something, you know, that's suggesting something else is at play here. So what scientists are attributing this to at the moment is global warming. So what is global warming? So the next picture shows you the greenhouse effect. Now, the greenhouse effect is where energy from the sun is coming into the Earth's atmosphere. Now, some bounces off the Earth's atmosphere, but some enters the atmosphere, reaches the Earth and warms it up. Now, via evaporation, some of that energy can come back out. But if you've got these greenhouse gases, so that's anything, so that's carbon dioxide, methane, water vapor, ozone, these kinds of things, they're present in the atmosphere. They absorb this energy, and now they serve to reflect some of this energy back to the Earth again, causing this trapping effect, much like a greenhouse when you're growing plants outside. So that's why they call that the greenhouse effect. Now, if you have too many of these greenhouse gases, then this effect worsens, and we see a warming of the planet, just like we saw in that graph just now. So too many greenhouse gases in the atmosphere, too much warming, okay? But the greenhouse effect was originally a good thing because it warms the planet up enough so that life could form on the planet. But too much, and we start going the other way.